Hello and welcome back to CST 2120. So in this lecture I'm going to introduce the MongoDB database. So I'm going to start with a sort of general overview of how databases work and a couple of the more popular types. Then I'm going to talk about database management systems, which is the software that kind of handles the file system that actually contains the database. And then I'm going to sort of talk about how MongoDB works. Right, so database is a program that enables you to store and retrieve data. So obviously, some of you may have used text files or something like that to store and retrieve data, but databases are kind of a step way and far beyond, what you can accomplish just using a text file for that, yeah? So most commercial websites use databases, a lot of academic projects use databases, they're absolutely everywhere, yeah? And there's two kind of main sort of types of database, right? We've got the sort of more traditional relational databases, which some of you may be familiar with, and then we've got NoSQL databases, which is the main sort of topic of this kind of lecture in the second half of this course. So relational databases organize the data into tables, and these tables have relationships between them, often called kind of foreign key relationships. And then with relational databases, we have what's called the structured query language. This is used to access and store data. I'll give you a few examples of that. Again, some of you are probably familiar with SQL. And with a relational database, there's a set of properties called ACID properties that sort of every relational database must have in order to ensure consistency in the data within that database. So this is a sort of very classic kind of relational database. Here we have different tables, and each table has one or more fields in it. So we might store a contact, for example, there's contact ID, address, city, phone, customer, and so on and so forth. And then there's these kind of foreign key relationships between the different tables. So one table might store, the customer details, another table might store the orders, and there'll be a foreign key relationship between the customers and the orders table. The sort of customer ID might appear in the orders table, so we can know which customer made that particular order. And with relational databases, we use SQL to access and manipulate the data. We've got select, update, delete. It's quite a complicated programming language. Well, it's not really a programming language, it's like a query language. It's quite a complicated language. You can go quite deep into it. And if you do my module next year, that's covered there, yeah? And then we have these ACID properties, which are a set of properties that all relational databases must have to ensure that the data within them goes from one consistent state to another consistent state, and this sort of transition is known as a transaction, yeah? So they have to be all or nothing, these transactions, that's the atomicity constraint. So if one bit of the transaction fails, then the entire transaction fails. And we have consistency, so the idea with a relational database is a transaction takes the data from one valid state to another valid state. There's isolation. So if we're working in parallel, then the effect of working in parallel should be the same as a serial or non-parallel execution. And durability means that once we've committed a transaction, it should be, the database should remain in the new state, even if the software managing the database crashes. Yeah. So if you remember, if you go back to here, like this sort of classic example of a relational database, we have a bunch of tables and relationships between them. So a transaction will take the data in all these tables from one state into another state. And because of these foreign key relationships, if we're modifying one table, that can often have impacts on some of the other tables. And so that's what it means by consistent state, with all the tables sort of nicely sort of linked up together in the way that we designed the database for. Yeah. So there's lots and lots of relational databases out there. Sort of Oracle is sort of one of the more powerful, kind of solid kind of commercial offerings. MySQL used to be an open source one, now it's sort of been taken over by Oracle. I'm not quite sure what's happened to it. It's now sort of the sort of fork of MySQL has become called MariaDB. There's a Microsoft SQL Server, we've got Postgres, and there's a few others of these out there. Yeah, SQLite, from what I remember. Now with relational database, remember we've got all these tables, we've got complicated relationships between these tables. And at some point, we're going to hit the problem of having to move that database running on a single machine, where it's quite easy to maintain data consistency and those ACID properties. And at some point, we're going to need to move that database and split it across multiple machines, because we might have loads and loads of requests per second, and that single machine just can't handle those requests. Yeah. So yeah, we need to run database across several machines. And so if we're taking a database with these tables and relationships between them, we need to figure out a way of just taking that database and breaking it apart and so it can put different parts of that database onto different machines. And this is a problem about sort of synchronization and sharding, as I'll come to. Yeah. And sort of when this problem started to emerge, maybe 20 years ago, people developed different kind of strategies to kind of solve this problem. We can kind of copy the data onto various read-only machines, merge data as it occurs, split data across machines. If we can put some customers on one machine, other customers on other machines. Well, this is all quite complicated stuff, and it's not so easy to do. Yeah. Although saying that, now people have got better at this. So the story I'm telling here is the emergence of NoSQL databases. But now relational databases can run pretty quickly in the cloud, and so some of these sharding issues have been resolved. Yeah. But during the when sharding was a big issue, people kind of looked for other solutions to this, and one of the solutions they hit on was NoSQL databases. So people said, well, these ACID requirements are great, but we don't really need all of them. And what we really care about is having a really scalable database that we can handle millions of users, at the same time. Yeah. So if we're running database behind Facebook or something like that, right, we need massive database. Yeah. And so, your single database running on a single machine is just not going to cut it for that. Yeah. So just in order to achieve this kind of high, scalability and speed, people came up with different designs for databases that were more simple, were faster, and were much, much easier to scale. Yeah. And so these kind of NoSQL databases have become quite popular in cloud computing and web applications. So there's a few of them. So there's key value stores, a bit like a hash map. So DynamoDB is kind of a classic. Again, I teach that in my third year module. We've got document stores, which are covering here, which is kind of, we have documents structured, typically with JSON. And then there's sort of more niche ones. We've got graph stores, wide column stores, and there's vector stores become quite popular, I think, with large language models. So, these are a few examples: MongoDB, DynamoDB, Apache Cassandra, and obviously in this lecture I'm going to be focusing on MongoDB, which is, pretty popular NoSQL database. So that's, so we often refer to, MongoDB or MySQL as a database, but and that often leads to confusion. Yeah. So I want to just talk a little bit about what a database management system is and how the whole database architecture kind of works. Yeah. So database management system is a software that manages the database files. Yeah. And that software will sit there as a server, effectively. It's listening on a particular port. And then other programs connect with the database management system, and they send their instructions to the database management system to store data and retrieve data. And then it's the database management system that accesses and modifies the files where the data is stored, and it'll have various optimization strategies to ensure that they can retrieve the data and search the data in a kind of blazing as fast a way as possible. Yeah. And so this database management system may be called the database server. So when we come to Mongo, it's not called the Mongo database management system, it's just called the Mongo server. Yeah. So this is kind of how it works. Yeah, you've got so you have the file system, because obviously ultimately we're storing that data in the database. The database data we're storing on the file on a hard disk or something like that, yeah, or SSD drive, whatever it is. And then here in the middle here, we have the database management system, which is this server that sits there listening on a particular port. I think it's like 27,000 something for Mongo. It's 3306 for the MySQL database management system. And so it's sitting there waiting for connection on a network. Yeah? And then multiple different programs can talk to that database management system over the network. So we can have a graphical interface. We're going to use Compass, MongoDB Compass is the graphical interface I'm going to be using in this course. We have the command line interfaces, so MySQL is command line interface, MongoDB has a kind of shell interface you can use to query and interact with the database. Then you're going to write JavaScript program that stores and retrieves data to and from the database. That also talks over the network to the database management system. And, in my third year module, we're writing Java programs that do the same thing, that kind of do web scraping and store the scraped data, in the database. Yeah. But the key thing is not to confuse, not to confuse all of these kind of different, graphical tools, programs, and so on and so forth with the database management system itself. Yeah, I'm often asked, people look at, Heidi or Compass or something like that and say, oh, that's the database. Yeah, but no, it's not the database. The database is here. The database management system is here. This needs to be running before any of these tools will work. Yeah, if you haven't got a MongoDB server or MySQL server, If that's not running, then you can't talk to the file system. All these things will just break, yeah? So don't confuse the database management system with the graphical tools that are used to interact with the database, yeah? Now, relational database management systems use SQL language to interact with the data, yeah? So these various programs here, yeah, like the graphical interface, you might write some SQL in here. That'll be sent over the network to the MySQL server, sitting there, the database management system, and then that'll do things in the file system depending on which SQL commands you send over the network, yeah? And that's true of Postgres, MySQL, MariaDB, and Oracle, and so on and so forth. So we send these SQL commands over the network to the relational database management system, and most relational database management systems will support a kind of core set of SQL functions or commands, yeah, queries, whatever you call them, yeah. Now, a similar thing happens with no SQL database management systems. So it's kind of the key difference is that instead of sending SQL, the structured query language, over the network, what we're going to do is send MongoDB commands over the network. So the MongoDB commands, as we'll cover in later lecture, are kind of basically different commands we can use to interact with the data, and we're using JSON to sort of fine-tune to identify the documents that we want to manipulate or insert. Yeah. So these MongoDB commands include like find, insert one, and so on and so forth. We cover in a later lecture. So MongoDB, it's a no SQL database, and that means we're not using SQL to interact with the database. We're using a kind of more of an API approach where we just make different calls to these kind of different MongoDB commands in order to be able to do some different things to the data. Yeah, there's different ways we can kind of interact with these things. So I'm going to show you how to get a MongoDB community server running in the cloud, but that's more of just a conventional database management system listing on a particular port in the cloud. But other kind of cloud databases, they have their own kind of API kind of method for talking to the database. Yeah. Okay, so that's the kind of core that's an outline of the field, so to speak. Yeah, we've got these relational databases, and then in order to kind of improve scalability and other properties, right? I mean, MongoDB, for example, has some very nice properties to do with document storage. It's not just, some kind of hack to run fast. Kind of is that, but it's also a really nice way to kind of store and manipulate data that avoids, some of the complexities and hassles of using SQL and relational databases. So let's now introduce MongoDB, this kind of NoSQL database, and explain how it works. Yeah. So it's a document database based on JSON. Yeah. So the core of MongoDB are documents structured in JSON. I'll talk about the structure in a bit. And then these documents are then organized in collections, and a database is just a grouping of collections, brought together kind of thing. Yeah. It's high performance, very easy to scale. And it has some ACID properties, but it's not completely ACID compliant. So, you've got this whole sort of idea of a kind of a transaction being a transition from one consistent data to another consistent state of the database. With MongoDB, it's a bit fast and loose. If you've got sort of foreign key relationships kind of thing between your documents, then MongoDB is not going to check them or enforce them. It's down to you and your code to make sure that everything works as you expect it to work. Yeah. So it's based on documents, which I'll come to in a little bit. So it's kind of middle rankings in terms of not middle. It's quite high, right? It's number 5 out of 10 out of the top 10. That's not bad here. So you can see here, this is like recent database rankings. I think 2023. Yeah. So these are the sort of top 4 databases are kind of SQL databases. And MongoDB, at least according to this survey, comes in at 5th in terms of which makes it the top NoSQL database. So it's based around documents. These documents are in JSON format. So that's why we covered JSON last term. And part of the reason we're using MongoDB this term, so we can get a deep understanding of JSON, which is absolutely crucial to understanding how to use the web and build web applications. It's document JSON format. Key value pairs, we can have this kind of complicated nested structure. It supports all the JSON stuff like arrays and objects and kind of thing. But there's no sort of, within a collection of documents, we can have all kinds of different shapes and forms. There's no particular structure of a document that has to be, present within each collection. Yeah. So, and you can think of loosely, if you think of a relational database, you have a table, and each table has a row with, each customer's information in it. A document's a similar thing. Yeah, it contains like a sort of certain chunk of data organized in a particular way. So this is a very sort of typical sort of MongoDB document. And the the sort of unique thing about MongoDB documents is they always have this ID field. So it's sort of underscore ID. You have to handle that in very specific ways when you write program code, as I'll show you. So we have a unique ID associated with each document. So, and this ID is like a 12-byte hexadecimal number, and it has certain kind of, each of the bytes has certain meaning associated with it to make sure that every document's unique, yeah? You can create your own IDs, you can, make your own, that's allowed by MongoDB, but I strongly recommend you don't mess with the IDs, yeah? The IDs ensure that all the documents within your database have a unique ID, and if you mess with it, then that's going to create trouble for you, yeah? So just let MongoDB automatically generate the IDs, and then you can use those IDs as foreign key relationships if you want. That's not a problem at all, but it's just best to let it do its own generation of IDs. Then inside the document, apart from the ID, you have the data, right? And this is standard kind of, this should be, have quotation marks technically, but anyway, let's not worry about that now. It's just an example. So these are keys like title, description, whatever, storing, in this case, strings, but you can store all the standard stuff you can do with JSON. The usual stuff is strings, numbers, and booleans, yeah? Then we can have arrays, just like you have with standard JSON, and then you can get real complex, like here we've got comments, which is an array of objects, within which each of which is like a little blob of JSON having its own, storing its own piece of data, yeah? So everything you can do with JSON, you can do with a MongoDB document data. So you got, the structured arrays, and then a collection is a group of MongoDB documents, yeah? And collections allow you to group together documents that have a similar purpose and structure. Like I said, the structure of these documents is not made consistent by Mongo in the way that a table is in a relational database, but that doesn't mean that you shouldn't try and ensure some kind of consistency within the documents within a collection, yeah? So typically we'd have things like products and customers and so on and so forth of an e-commerce website, and we'll talk later about the kind of collections that might be sensible for your social networking website for Coursework 3. So similar to a table, but like I said, with a table, every single row has to have the same fields in it, right? With a MongoDB collection, each row could have different fields in it, yeah? It's more of a sort of organizing thing for the people who write the code for the web application or whatever they're doing, yeah? And then a database, simple, holds one or more collections. So a good way to think about collections is like a folder containing documents, right? And if you would just have a folder with documents on your PC or something, then, these documents could contain all kinds of different stuff. And on your PC, there might be different formats like PDF, Word, and so on. But in MongoDB, these are all JSON format. So this can be thought of as a folder, and this is like a collection of a group of folders, yeah? Now, in order to use MongoDB, we have to be able to query the documents, and we have like a JSON-based query language, yeah? So we can use JSON to like search for all documents that have a certain name field entered with a certain value, and we can do indexing on it and all the kind of standard stuff we expect to do in databases. But instead of using SQL, we're using this JSON-based query language designed by MongoDB. So just to kind of get clear here, but for those of you who are used to relational database management systems, both of them have the root concept of a database, and then we've got kind of so if you remember what a relational database is, kind of tables with rows and so on and so forth, whereas Mongo has these kind of collections. So very roughly, a table corresponds to a collection. So this is a group of documents. This is like a group of rows with all the same structure. In this case, different structure can be within different documents of different structure can be within a collection. And then each row within a relational database, rows within these tables, this is just the table headings here, would correspond to a document, which is the document in MongoDB, yeah? And then, field corresponds to a column, and let's not get too fancy about the rest, yeah? So there are some nice advantages. You don't, obviously relational, if I was building a banking system where I want really solid transactions, and I want my database to go from one system to another state, one state to another state, in a really consistent way, then I totally would not use MongoDB, right? For a banking system, I'd use a relational database without hesitation, yeah? For a government system, the same thing, yeah? But if I was building an e-commerce website where I have lots of different products with different properties and so on and so forth, and I wanted something really fast and scalable, then MongoDB would be a really good choice, yeah? And so it really depends on what kind of application you're building, whether you want to use a NoSQL database like Mongo or a relational database like MySQL, yeah? But definitely MongoDB for certain applications has real advantages because it's a very nice JSON thing, which means it's fast, it's very easy to scale, and it's very, very easy to integrate with JavaScript. Yeah, so I took out the slides on this, but historically, there's people used to use relational databases with kind of PHP, and that was like a sort of traditional way of building commercial websites. But we've moved over to kind of more of a using JavaScript and using MongoDB, because if you've got retrieve a document from MongoDB, it's already in JSON format, so you can instantly convert that into JavaScript. And then just work on it as a JavaScript object. So this ability to work nicely with JavaScript is a real advantage for MongoDB. Relational databases can quite easily be converted to JSON, but not to JavaScript objects, but not quite so easily. Yeah? So that's what MongoDB is. Of course, you must use MongoDB. So you're going to create databases, collections, and documents for your proposal. And you're going to write JavaScript code that stores and retrieves data to and from MongoDB for the final submission. Yeah, well, both for the web service and the final submission, for the second and third submission. Yeah. Now, there's two ways in which we can get MongoDB running. There's a cloud MongoDB called Atlas, and also you can install it on your local machine, or I've also provided a portable version that you can get running on your local machine. It's a Windows portable version. So I'm going to cover those separately and just keep this as a sort of short introduction to MongoDB. So this lecture has introduced MongoDB. It's a NoSQL database that stores JSON documents. The query language for it is also based on JSON, and you have to use it to build your social networking application for Corso 2. And that's it.